Let's talk about compound interest. So here's the formula for compound interest. One of my favorite formulas to talk about. The amount, the A stands for amount, that you have in the bank is equal to the principal times. Now here's how I'm going to create this. I'm going to take 1, because when I multiply that P back in, it's going to give me my principal back, and then I need to add interest to it. So the interest I'm going to add is equal to the rate. It's equal to whatever the rate is divided by the number of times I compound it, and then I raise that to the nt power. And here's what this is doing. Let's say that I had $1,000 and my rate was 5%. Then I would be, let's say that it was compounded annually. Whoops, 0.05. I would multiply 1,000, my principal, by 0.1 plus 0.05, and what that's going to do is going to give me 1,000 plus 5% of 1,000, and that's my interest portion. That's my principal portion. When I add them together, I get my total amount.
I'm going for the 100%.
That's how that formula works. Now, why do I have to divide it by n? Well, because I'm sorry, let me show you one more thing. And then I would raise this to the t power, however many years, because then I'm going to multiply it by, let's say my next amount after the first year is $1,050, because I had made $50 in interest. Now I multiply it again by that same thing for the second year, and it compounds the interest, and that's why it's raised to the t power. Okay? Now why do I divide it by n and multiply it by n? Well, if I'm compounding it more than once a year, I have to divide that. Let's say I'm dividing it every month. I have to divide that rate by 12. I can't compound the full rate every month. I compound 1/4 of the rate every month, but I compound it 12 months for every year. So I'm compounding it more. The rate is smaller, but I'm compounding it a lot more often, and that's why the more you compound it, the higher your amount will be. Like the more often you compound it. All right. So the question is, what does this have to do with the PERT formula? And the PERT formula, if you were to take this formula right here, that E, the letter E, which is 2.7 blah 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 whatever, it's like pi.
Yeah.
It's a transcendental number. That number right there is a naturally recurring number that magically, I don't even completely understand why, but that number has to do with exponential growth and decay of things. And so if you were to take this, let's say you were to compound an amount of money, you can even do this. This is an activity you may have done in class sometime. If you were to take this, no, let's just take an example. Let's say I want to find the amount. If I compound $100 and I want to compound it at 5%, and I want to compound it 1,000 times a year. So I'm going to raise this to 1,000 times the number of years that I have. If you were to compute this number right here, you compute this amount, let's say I wanted to figure out for 3 years. If you were to compute that number right there, you're compounding it 1,000 times a year. And if you were to compute this number right here, e to the 0.05 times 3, if you were to compute those two numbers, this number right here would be slightly larger than this number right here. Because this number, the PERT equation, is the limit of, it's like the max, it's the limit to, as you approach, as this number right here, the number of compoundings gets bigger and bigger and bigger and bigger, it approaches this number, but it never reaches it. It's a limit. It's like an asymptote. It's like an asymptote concept. So that's the reason, that's the idea behind compound interest formulas and the PERT, the continuous compounding, because continuous means some brilliant doctor or banker decided, hey, I'm going to tell everybody that I'm compounding it every millisecond of the day. I'm going to compound it. And it sure sounds like they're going to be billionaires, but there's a limit to it, and the limit is that PERT equation. He knew that there was a limit to it. It doesn't matter how many times you compound it, it's not going to be unbounded. The bound is the PERT equation. That's how that works.